Assalamu alaikum dear students, welcome you all. Bismillahir Rahmanir Rahim. Today inshallah we will continue our new lecture series, that is designing and analysis of simply supported beam. Okay, so in previous lecture you see that how we will analyze the different overhang beams. Okay, there may be singly overhang and there may be doubly overhang, and for different types of loading, that the loading may be moment, the loading may be UDL, and the loading may be point loads. Clear? So basically here we are going to analyze the simply supported beam. Clear? And you can see that there we have a simply supported beam, clear, with a point load and a moment. Clear? So let's see how we will design this beam. Clear? So let's say starts. Clear? Bringing a new template. Let's say you first need to make sure your units will be found foot and found foot. Clear? So you need to select the beam template. Okay, here you have to select only one span, because you see that in this type of beam we have only just one span. Okay, A and B. Clear? So we have only one span, and one thing you must remember, that there is only the arrow signs. So you can assign this joint as a ruler support, and you can assign this support as hinge. If you assign this structure as a ruler, then you will assign this A support will be as hinge support. Clear? So basically if you assign both of these supports as ruler, okay, so you can assign this as a ruler. Okay, but on if you look to this structure now on equilibrium basis, this is an unstable structure. Clear? And therefore we will select unstable, because this structure can move in horizontal direction. Okay, so therefore it is unstable. It can move in y direction, although it is safe. It cannot move in vertical and upward direction. Okay, upward and downward direction, but this structure can move in horizontal and y planes. So therefore you must need, from equilibrium point of view, you must assign one ruler and one hinge support. Clear? So let's say we will start. We have this kind of simply supported beam. Okay, and we have one span. Okay, that is a span of 3 plus 6 plus 3, that is 12. Okay, so we have one span. Clear? And a span length is 12 feet. Okay, and just we don't need now grid spacing added. Clear? So remove it. Okay, this window, and make sure that you will be in exit line. Clear? So this is AB span. Now just check this support, whether this support is hinge. Okay, and whether this support is ruler or not. So make it ruler. Clear? Now we need to assign just only loads. Clear? So 2000 pound at a distance of 3 feet. Clear? So select it, assign frame loads and point. Frame loads and point. Clear? Now point load. I want to show you another way that how we can make we can disable the self-weight multiplier. Okay, so let's see. You need to select the define menu. Okay, here you can you will select section properties, clear, and then you will select frame sections, clear. Here you will select modify or show property, and there you can select set modifier, and this set modifiers you will make the weight equals to 0 and mass will equals to 0. These are the self weight multipliers. If you make them 0, don't consider the mass and weight of the beam. Clear? Okay, okay, and okay. Clear? Now we will assign the loading. Okay, frame load and point load. Now this you don't need to click on dead load and the previous step. Okay, you just need to press this button, found feet, clear, and you need to assign loads. Gravity direction, load will be in downward direction. Okay, and you need to assign now loads. The load is acting at a distance of 3 feet. Okay, the load is acting at a distance of 3 feet. Clear? You must sure that you select this beam. Your 0 distance will be counted from this side, and the distance will be counted in this side, and it will be 12 feet at support D, which is in SAP is support B. Clear? So this distance is now 3 feet. Now this distance is basically 3 feet. Okay, and a load intensity is 2000 pound. Clear? And just clicking OK. So your load is assigned right now, and then we will assign basically our now our moment, which is in anti-clockwise direction. So you just need to insert the value of moment with a negative sign. Clear? With a negative sign. So therefore, and the moment you must need to compare the moment direction with your symbols. Okay, your axis, sorry. So this is your axis, this is your x-axis. Okay, this is 1 1. This is your y-axis. This is 3 3, and this is your z-axis. This is 2 axis, or you can say this is your z-axis, and this is your 3 3 axis. Clear? Or you can say this is y-axis. So, and this is your x-axis, or you can say 1 1. Clear? So you can see the moment is right now acting about the 3 3 axis are about y axis. Clear? So you make sure that you apply the moment about the appropriate axis. Clear? So there we will assigning the moment. Clear? You must select point load. Okay, and there found feet moment. This moment option should be selected. Clear? And now you need to select y axis, because the moment is applied about y axis. Clear? And you need to apply the moment at a distance of 6 plus 3, which comes out to be 9 feet. So the moment will is acting at a distance of 9 feet. Clear? And its amount is 4,800 pound feet. 4,800 pound feet. Okay, and press this button. Clear? Now, okay. So the moment is assigned. If you want to see the moment, you just need to change the view. No, we make a mistake because we assign a clockwise moment, and the moment is basically acting in anti-clockwise. So remove the load by just clicking Ctrl Z button. Make sure you will be in XZ plane and select the beam, assign frame load, point. You just need to insert a negative sign in front of minus 4,800. Clear? So 800. Sorry, this is not. So add to existing loads about Y. All option is are okay. So let's see. Go to 3D view, and now your movement will be in anti-clockwise direction. So you will assign the joints, loads, and just press the run button. Okay. This is simply supported beam with a point and a movement. Clear? And save the file. Clear? So now first of all we will check the reactions. 1900 are A and our B will be 100. So let's see. You need to press this show forces and stress button, select joints, and now okay. So 1900 and 100 reactions are okay. Let's see, we will see the reactions. 1900 and 100 pounds, the shear diagram will be okay. If you want to check it, so let's see this one, shear about 22, show values, okay. So this is the shear force diagram. Clear? It is a very minimum value, okay. So this is 1900 and this is positive 100 pound, okay. Now we check the moment diagram, okay. Let's see, moment about 33, okay, moment about 33 and okay. So this is your moment diagram. The maximum moment is 5700. Clear? 5700. Okay. And you know, there is a very little bit, change. Clear? If you want to show this, you can check it from there. Okay. So you can remove your cursor as well, okay, and you will examine that what will be the value. So your maximum value is 5700, and there you can see 5700. Clear? So basically these are the steps which is followed for to that how we will analyze, there will be 500 and there will be 300 found, okay. So this is the way that how we analyze a simply supported structure. I hope you will learn this video, and in coming lecture I will present a new simply supported structure with a different types of loading. Clear? If you have any question, I welcome. Okay, thank you.